Hi, welcome to Nomis Academy. In this video, we'll be talking about binomial expansion. I know that's big, but what we do there is as simple as what you are familiar with. Binomial expansion. Binomial expansion. And this, we're going to have a series of videos on binomial expansion because we deal with binomial equation, and binomial equation can be done using number one, Pascal triangle. Pascal triangle. Pascal triangle. And combinatorial analysis. Combinatorial analysis. Combinatorial analysis. So we will take them one after the other. So in this video, we'll be dealing with Pascal triangle. What is Pascal triangle? You see, Pascal triangle is a formulated triangle in which each line of the triangle carries the coefficient of the term in the expansion of binomial equation. I take that again. Pascal triangle is a formulated triangle in which each line of the triangle carries the coefficient of the term in the expansion. Carry the coefficient of the term in the expansion of binomial equation. So let's see what I'm talking about. Let's say we have x plus y squared. This is equal to x plus y multiplied by x plus y, and x times x is x squared, x times y is xy, y times x is xy, plus y times y is y squared. So this is x squared. Xy plus xy is 2xy, that is 2xy plus y squared. So what are the coefficients of x and y here? The coefficient here is 1, the coefficient here is 2, and the coefficient here is 1. So that means x plus y raised to the power of 2 have these coefficients. Let's check the other way around. What if it is x plus y raised to the power of 1? We'll definitely have x plus y, and the coefficient is just 1 and 1. So what about x plus y raised to the power of 0? We are going to have the coefficient 1, because anything raised to the power of 0 in mathematics is 1. So look at the coefficients here, 1. When we have raised to the power of 1, we have 1, 1. When we have the coefficient to the power of 2, we have 1, 2, 1. So this is what Pascal studied to come up with what we now know as Pascal triangle. So let's take that in Pascal triangle. Let's see what we can do with Pascal triangle. Pascal triangle says 1 is the coefficient first, then we have 1, 1, then it says we have 1, 2, 1. Then it studied the pattern to say, okay, there is always a 1 at the beginning. 1 plus 2, 3. 2 plus 1, 3. And then lastly, we should have 1. 1 must start from the beginning. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And then 1 ends it. 1 begins. 1 plus 5 and 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And lastly, 1. So we have 1 from the beginning. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And lastly, we should have 1. You can see how this is forming a triangle. So let's take the last one here. 1. 1 plus 6, 7. 6 plus 15, 21. 15 plus 20, 35. 20 plus 15, 35. 15 plus 6, 21. 6 plus 1, 7. And lastly, we should have 1. You can see we are forming a triangle. So Pascal says that this follow this pattern coefficients. So that let's take a plus b all raised to the power of 0. This is the coefficient. The second one says a plus b raised to the power of 1. So the third one says a plus b raised to the power of 2. Then the next one is a plus b raised to the power of 3. A plus b raised to the power of 4. The next one is a plus b raised to the power of 5. The next one is a plus b raised to the power of 6. And the last one that we have here is a plus b raised to the power of 7. So when we open this value, when we expand this value, we are going to have a and b multiplied together in the coefficients of 1, 7, 21, 35, just as this Pascal triangle has been able to discover. So as you can see, a triangle has been formed. So this whole entire thing is what we call Pascal triangle, and it is applicable in expansion of binomial equation. Let's take an example. Example 1. So the question is asking that using Pascal triangle, expand a plus b raised to the power of 4. So how can I use the Pascal triangle now to expand this? So let's get into the solution. So since a plus b raised to the power of 4 of Pascal triangle as the coefficient, you know what Pascal did was to bring out the coefficients. So the coefficients are 1, 4, 6, 4, and 1. So if you watch carefully, you take your time to study when it is 0, 1, when it is 1, 1, 1, and when it is 2, 1, 2, when it is 3, 1, 3, 3, 1, when it is 4, 1. After 1, that power, 4, then 6, then 4, then 1. Where did I get this 6? 3 plus 3. Remember, that gives me 6. Then you know 4 will come next again, then 1. So this is 5 this time now. So 1, 5. So after that 5, remember what you have in the middle here. 6 plus 4, 4 plus 6, you have a 10. So 6 plus 4, you have a 10 again. Then 4 plus 1, you have a 5, which is the power. And then you have 1 again. So you take time to study this Pascal triangle to have it in your memory, so that anytime you need it to solve a binomial equation, you will be able to solve them. So let's check. So now that I know that these are the coefficients, so let's take it. A plus b raised to the power of 4. Is it not the same with a plus b raised to the power of 2 multiplied by a plus b raised to the power of 2? Isn't it? Yes. And I know that a plus b raised to the power of 2 is a plus 2ab plus, a squared plus 2ab plus b squared. Now multiplying a squared plus 2ab, plus plus b squared. So by the time you put them together, a multiplied by a squared multiplied by a squared, we have a raised to the power of 4. The same a multiplied by this, so that's 2a raised to the power of 3b the same a multiplied by b, so that's a squared b squared. Now we take the second one, plus 2ab multiplied by 2 by a squared, so that will be 2a now in 3 places, then b, plus 2ab multiplied by 2ab, so that's 4a squared b squared. 2ab multiplied by b squared, that's plus 2a b raised to the power of 3, plus, now we go to this b squared. So b squared multiplied by a squared is a squared b squared, right? So that's plus a squared b squared, plus, now b squared multiplied by 2ab, so that will be 2a b raised to the power of 3. Now plus b squared multiplied by b squared, that will be b raised to the power of 4. So we could collect like terms and add them together. A4, do I have any other 8-4 standing on its own? No, so just A4 plus 2a cube b. We have 2a cube b. We have another 2a cube b here. Do we have another a cube b? No. So 2a cube b plus 2a cube b is equal to 4a cube b plus a square b square. So we have 1a square b square. We have 4a square b square. So that makes it 5a squared b squared. We have another a squared b squared here, 1. That is 6. So that makes it 6a squared b squared. So plus a cube, okay, we've calculated this, a squared. Then we have 2ab b cube, a b cube, 2ab cube. Do we have another ab cube? We have another 2 here, 2ab cube, 2ab cube. So that will be 4ab cube. So plus b raised to the power of 4. If you take out the coefficients, you see that the coefficient here is 1, the coefficient here is 4, the coefficient here is 6, the coefficient here is 4, and the coefficient here is 1. So we now have 1, 4, 6, 4, 1. So these are the coefficients that Pascal did out of his study in making out the coefficient for expansion of binomial equation. Also, you will note the changes in power. The changes in power. What do I mean by changes in power? When A is carrying 4, remember that what we are to expand is A plus B raised to the power of 4. When A is having a power of 4, B is having a power of 0. So that's just what we are doing. So when A is having a power of 4, B is having a power of 0. So that when A is now having the power of 3, B is having a power of 1. So as the power of A decreases, the power of B increases. As the power of B increases, the power of A decreases. So A here is having power of 4. There is a B here, B raised to the power of 0, but already B raised to the power of 0 is 1, so there's no need to write it. So this is how he came up with it, that without doing all of this calculation, if I know what it is, A plus B, right? So I could just start with A raised to the power of 4 multiplied by B raised to the power of 0 plus A raised to the power of 3 multiplied by B raised to the power of 1, A raised to the power of 2 multiplied by B raised to the power of 2. You can see they are equal here. Now, A is reduced again. You know, A has been reduced 4, 3, 2, then 1 until A no longer exists, and then B now access to the power of 4. So once I'm able to get the AB combination, I can now just put my coefficient as the work of Pascal Triangle, as Pascal has found out. So that says that the power of A decreases from 3 to 0, and the power of B increases from 0 to 4. I hope you understood everything we did in this video. Take your time to watch out and study that you could expand a binomial equation without going through a lot of calculations, just by getting your A and B, or whatever that you need to expand, whether X and Y as the case may be, in the power that you are given to expand, and then input the coefficient that Pascal Triangle has taught us. Bye bye. See you in the next video.